In exactly 12 days from this moment, something absolutely unprecedented in the history of modern astronomy will occur. An object designated as 3I Atlas, traveling from beyond the boundaries of our solar system at velocities that confirm its interstellar origins, will disappear behind the Sun at precisely the moment when scientists need to observe it most critically. The timing appears almost surgically precise, almost impossibly coordinated. Astronomers worldwide have been tracking this mysterious visitor for months, with an intensity rarely reserved for objects passing through our cosmic neighborhood. Every measurement taken, every spectrum analyzed, every image captured reveals something that categorically should not exist according to our current understanding of cometary science. The data is staggering. An 8-to-1 carbon dioxide to water ratio that sits 6 standard deviations beyond anything ever recorded in any comet throughout the entire history of astronomical observation. Nickel emissions displaying patterns and ratios that resemble industrial metallurgical alloys far more closely than they resemble primordial ice formations from the dawn of planetary systems. A trajectory so precisely aligned with 3 different planets in our solar system that when statisticians calculate the probability, they arrive at odds of approximately 1 in 20,000. And now, just as the most intense solar heating should force this enigmatic object to reveal its fundamental nature and true composition, it vanishes behind 965,000 miles of incandescent plasma. For several critical weeks, we will be completely and utterly blind. December will ultimately tell us whether the same object emerges on the opposite side of our Sun, or whether something fundamentally different appears in its place. Right at this very moment, 3 massive coronal mass ejections are systematically hammering Earth's protective magnetic field as this comet races toward its closest possible approach to our star. In less than 2 weeks, during this astronomical blackout period, during the singular window, when something could theoretically perform a complex deceleration maneuver without any possibility of detection from Earth-based or Earth orbital observatories, every single telescope on our planet will be pointed uselessly at an impenetrable wall of stellar fire. Certain calculations performed by respected astrophysicists suggest that if anything with technological capabilities wanted to break and enter a permanent bound orbit around our Sun, remaining in our solar system indefinitely rather than continuing on a hyperbolic escape trajectory back into interstellar space, hidden behind the Sun would represent the mathematically optimal moment to execute precisely that kind of maneuver. The accumulated improbabilities surrounding this object have reached a threshold point where simple dismissal actually requires more faith in coincidence than serious consideration of alternative explanations. Before we venture deeper into this profound mystery that may redefine humanity's place in the cosmos, I need to ask something critically important of you. If you're finding this content valuable, if it's genuinely helping you understand the universe and our cosmic situation in a fundamentally new way, please hit that like button right this instant. It sends a powerful signal to the algorithm that this type of deep, scientifically rigorous content matters to audiences, that people want substance over sensationalism. And if you haven't already subscribed to this channel, click that subscription button immediately. We're actively building a community of intellectually curious individuals who want authentic science, genuine mysteries, presented without manufactured drama, but with all the natural wonder they inherently deserve. Drop a comment down below telling me your honest thoughts about what you're hearing. Are you fundamentally a skeptic who thinks this is all natural phenomena being overinterpreted? Are you a believer who thinks we're witnessing evidence of extraterrestrial intelligence? Are you somewhere in the thoughtful middle, weighing evidence carefully? Your engagement directly helps this channel grow and provides me the resources and motivation to create substantially more content precisely like this presentation. Now, let me properly set the comprehensive scene for you with all necessary context. For many months, astronomers representing institutions across the globe have been observing 3I Atlas with an almost obsessive intensity rarely reserved for objects making transient passages through our solar system. The James Webb Space Telescope, humanity's most powerful infrared observatory positioned at the second Lagrange point, turned its extraordinarily sensitive instruments toward this mysterious visitor. The Hubble Space Telescope, still functioning magnificently decades after its initial deployment, captured the object's distinctive teardrop-shaped coma in exquisite detail that revealed unexpected structural features. Ground-based observatories, stretching from the Atacama Desert in Chile to the volcanic peaks of Mauna Kea in Hawaii, tracked every single movement with meticulous precision. Spacecraft currently orbiting Mars, including the European Space Agency's Mars Express and ExoMars Trace Gas Orbiter, along with NASA's Mars Reconnaissance Orbiter, prepared elaborate observation campaigns to photograph this visitor as it sailed past the red planet. This wasn't merely routine scientific curiosity or standard cataloging of solar system objects. This intensity of focus approached genuine obsession, and that obsession emerged from compelling, data-driven reasons that become more obvious as we examine the evidence. Every single measurement taken, every spectrum carefully analyzed, every image painstakingly processed revealed something that categorically refused to fit the standard scientific playbook we've developed over decades of comet observation. Intense carbon dioxide outgassing occurring when the object should have been essentially dormant at its distance from solar heating. Chemical signatures and emission spectra resembling industrial manufactured materials far more closely than primordial ice and rock that's been frozen since the formation of planetary systems billions of years ago. A trajectory threading between multiple planets with geometric precision that made probability experts and statisticians genuinely uncomfortable when they calculated the odds. And now, precisely at the moment when this object reaches maximum solar heating, precisely when sublimating ices should reveal the absolute most information about its fundamental composition and internal structure, precisely when we should be learning its deepest secrets through the most intensive observation campaign ever directed at an interstellar visitor, it disappears completely from view. The geometric situation is straightforward in concept, but intensely frustrating in practical terms. 3I Atlas approached the Sun from one particular direction in space, while Earth sits positioned on the completely opposite side of our star. For several critical weeks spanning late October through November and into early December, the Sun itself blocks our view entirely and completely. No telescope on Earth's surface, no observatory orbiting Earth, no instrument available to humanity can possibly penetrate through nearly 1 million miles of incandescent plasma radiating across the entire electromagnetic spectrum. Astronomers use specific technical terminology for this geometric configuration, calling it superior conjunction. From a purely observational standpoint, it couldn't possibly have arrived at a worse moment for scientific study. Or perhaps, depending fundamentally on your perspective and interpretation of the accumulating evidence, it arrived at exactly the perfect moment for something else entirely. October 29th marked perihelion, the point of closest solar approach, when 3I Atlas closed to within 1.36 astronomical units of our Sun's photosphere. To provide proper perspective and scale for those less familiar with astronomical distance measurements, the object passed closer to our star than Mars ever approaches during its entire elliptical orbit, sliding through an extreme environment region where temperatures soar to levels that would instantly vaporize any exposed biological material, and where radiation intensifies dramatically to levels lethal to unshielded life. This represents the crucible, the ultimate test. This is where comets composed of primordial ice and ancient rock either conclusively confirm their fundamental nature through predictable behavior or reveal something entirely different that doesn't fit our established models. When a traditional comet made primarily of primordial ice mixed with rocky dust and frozen gases encounters this intense magnitude of stellar heating, highly predictable phenomena occur that we've observed countless times. Water ice sublimates rapidly into steam vapor. Frozen carbon dioxide transforms directly into gaseous phase without passing through liquid state. Microscopic dust particles physically lift from the irregular surface, carried outward by the pressure of expanding vapor, creating visible jets and plumes. The fuzzy envelope surrounding the solid nucleus, technically called the coma, grows substantially brighter and dramatically larger in physical dimensions as more material sublimates. The iconic tail stretches millions upon millions of miles behind the comet, pushed outward by intense solar wind consisting of charged particles, and by radiation pressure from photons themselves. We've witnessed this elegant cosmic dance literally thousands of times throughout the history of astronomical observation. We understand the fundamental choreography completely, can predict behavior with high accuracy, can model the physics with sophisticated computer simulations. But 3I Atlas has never once followed this standard script throughout its entire observation period. And now, at the most critical juncture, we cannot observe its most important performance. The observation blackout isn't completely total, naturally. Other observational assets exist scattered throughout the solar system, though their perspectives are inherently limited by distance, viewing geometry, and instrumental capabilities. Spacecraft currently orbiting Mars managed to catch brief glimpses as this mysterious visitor passed within approximately 19 million miles of the red planet on October 3, 2025. The European Space Agency's Mars Express Orbiter and ExoMars Trace Gas Orbiter both directed their cameras toward the approaching object despite those instruments being designed and optimized for photographing planetary surfaces rather than distant faint objects. They successfully captured images showing a faint smudge presence against the background starfield, though the images required extensive processing and enhancement. These weren't detailed close-up portraits revealing surface features or structural details. From Martian orbital distances, 3I Atlas remained merely a point source, barely distinguishable from background stars without careful analysis. But the fact that observations occurred at all represents significant technical achievement, confirming the object's position, trajectory, and continued activity through that critical time period. However, what those images revealed raised more questions than they answered, showing unexpected asymmetries in the coma structure and suggesting behavior patterns that don't align perfectly with standard comet models. The story of 3I Atlas actually begins months earlier, in the middle of 2025, when the Atlas Survey telescope system in Chile first detected an unusual moving object during routine automated sky surveys. Descoberto oficialmente M1 degree de julho de 2025, o objeto imediatamente chamado atenção devido as suas características orbitais incomuns que sugeriam origem interestelar. Análises preliminares de trajetória mostram que 3I Atlas estava viajando em uma órbita hiperbólica com velocidade excedendo a velocidade de escape do sistema solar, confirmando, de forma conclusiva que este objeto não se origina ao redor de nosso Sol, mas se veio de além do espaço interestelar profundo entre as estrelas. This marked only the third confirmed interstellar object ever identified passing through our solar system in the entire history of astronomy. The first, designated 1I/Oumuamua, arrived in 2017 and immediately generated enormous controversy due to its highly unusual characteristics including extreme elongation, unexpected non-gravitational acceleration, and complete absence of any visible coma or tail despite passing close to the Sun. The second, designated 2I/Borisov, arrived in 2019 and behaved far more like traditional comets we're familiar with, showing expected outgassing, developing a normal coma and tail, exhibiting composition similar to solar system comets, thereby providing some reassurance that not every interstellar visitor necessarily challenges our fundamental understanding. But now we have 3I Atlas, and this third confirmed interstellar visitor brings its own unique collection of puzzling characteristics that place it somewhere between the mundane familiarity of Borisov and the profound strangeness of Oumuamua. From the very first observations, something seemed off about this object, something that didn't quite fit established patterns. Initial spectroscopic analysis performed just weeks after discovery revealed unexpected emission lines in the comet's spectrum, chemical signatures that seemed anomalous compared to the thousands of comets previously studied. As more powerful telescopes turned their attention toward 3I Atlas throughout July and August 2025, the anomalies multiplied rather than resolved. The Keck Observatory telescopes in Hawaii, among the most powerful ground-based optical instruments available to astronomy, performed detailed spectroscopic observations that mapped the distribution of various molecules in the comet's coma. What they found was genuinely startling to experienced comet researchers. The spectrum showed strong emissions from nickel atoms and cyanide molecules, which by themselves aren't unusual in comets. But the specific ratios and distributions of these emissions appeared strange, not matching patterns seen in any previously studied comet, whether from our solar system or the two previous interstellar visitors. The nickel emissions in particular caught attention because their ratios resembled industrial alloys more closely than they resembled primordial materials frozen since the early days of stellar system formation. This raised immediate questions about formation conditions, about what kind of protoplanetary disk could produce such ratios naturally, about whether we were seeing something genuinely unprecedented or simply underestimating the chemical diversity possible in alien planetary systems. Then came observations from the James Webb Space Telescope in early August 2025, and these observations elevated concern from interesting anomaly to this requires serious attention. Webb's extraordinarily sensitive infrared instruments can detect and analyze molecules that visible light telescopes miss entirely. When Webb observed 3I Atlas, it revealed something that made experienced astronomers immediately sit up and take notice. The comet's coma showed overwhelmingly dominant carbon dioxide emissions, with only trace amounts of water vapor. The specific ratio measured was approximately 8 parts carbon dioxide to 1 part water, making this by far the most carbon dioxide-rich comet ever observed in astronomical history. To put this in proper statistical perspective, this ratio sits approximately 6 standard deviations above the mean for all comets ever measured. In statistical terms, that represents an extraordinarily rare event, something that should occur less than once in a billion random observations if you're simply sampling from a normal distribution. Either we've discovered the absolute most extreme outlier possible in terms of natural comet composition, representing the far edge of chemical diversity, or we're observing something that formed under radically different conditions than anything familiar. Or potentially we're seeing something that wasn't formed by natural planetary processes at all. Each of these possibilities carries profound implications for our understanding of planetary formation, interstellar chemistry, and perhaps even more exotic possibilities. The carbon dioxide dominance itself can be explained through natural processes if you're willing to invoke special formation conditions. If 3I Atlas formed in a planetary system where the carbon dioxide frost line extended farther from the parent star than in our solar system, if the protoplanetary disk had unusual chemical composition favoring carbon dioxide formation, if the object formed in a particularly cold region where water remained more tightly bound. Then extreme carbon dioxide enrichment becomes plausible, if not highly probable. These represent reasonable hypotheses that don't require invoking anything beyond known physics and chemistry. But they do require very specific formation conditions that we haven't definitively observed occurring in any of the thousands of exoplanetary systems we've studied. The trajectory analysis added another layer of improbability to the growing mystery. Multiple research groups independently calculated 3I Atlas's precise orbit using observations spanning several months, and when they examined the results carefully, they noticed something genuinely unusual. The orbit brings this object remarkably close to not just one, but 3 different planets in our solar system during its single passage through the inner regions. On October 3rd, it passed within 0.19 astronomical units of Mars, close enough that spacecraft in Martian orbit could photograph it despite the enormous technical challenges. Earlier in its trajectory, it approached within 0.36 astronomical units of Jupiter and 0.65 astronomical units of Venus. 3 close planetary encounters during a single pass represents an unusual geometric configuration. Most objects passing through the solar system follow paths that might bring them near one planet if we're fortunate, but 3 close approaches suggests either remarkable coincidence or a trajectory specifically designed for planetary reconnaissance. When statisticians calculated the probability of this specific trajectory occurring randomly, they arrived at figures around 0.005%, or 1 in 20,000. Additionally, the orbital plane of 3I Atlas tilts only 5 degrees from the ecliptic, the plane containing most planetary orbits. Most interstellar objects should arrive from essentially random directions in 3-dimensional space, creating roughly isotropic distribution. Finding one so closely aligned with our planetary system's orbital plane represents yet another low-probability configuration. Individually, each of these characteristics might warrant a footnote in a research paper, interesting but not paradigm-shifting. But collectively, they form a pattern of improbabilities that makes even skeptical scientists pause and wonder whether they're missing something fundamental about what they're observing. By September 2025, 3I Atlas had become one of the most intensively studied objects in the solar system, with observing time allocated on virtually every major telescope facility worldwide. The European Southern Observatory's Very Large Telescope in Chile performed polarimetric observations, measuring how light reflects off particles in the coma. These observations revealed surprisingly high negative polarization at small phase angles, a characteristic typically associated with trans-Neptunian objects covered in organic-rich materials rather than active comets with fresh exposed ice. This suggested the coma contained a mixture of materials with properties quite unlike typical comet dust, adding yet another entry to the growing list of anomalies. The Hubble Space Telescope contributed high-resolution imaging that allowed researchers to estimate the nucleus size based on brightness measurements and reasonable assumptions about surface reflectivity. The results constrained the nucleus diameter to somewhere between 0.32 and 5.6 kilometers, with the most probable size being less than 1 kilometer across. That represents a remarkably small object for something exhibiting such vigorous and widespread activity. Small cometary nuclei have less gravitational binding energy. They hold onto volatile ices less efficiently. They should become depleted of their most reactive materials relatively quickly over cosmic timescales measured in millions or billions of years. Yet 3I Atlas was already bright and highly active in May 2025, when it was still 6.4 astronomical units from the Sun, far beyond the distance where water ice sublimates efficiently. This indicates the comet's prolific activity must be driven primarily by sublimation of supervolatile ices, chemical compounds that vaporize at much lower temperatures than water. Carbon dioxide fits this description perfectly, which aligns beautifully with Webb's compositional measurements showing extreme carbon dioxide enrichment. But it also means this relatively small object has somehow retained extremely volatile materials despite potentially billions of years drifting through the freezing void of interstellar space, where it would have been exposed to cosmic radiation, occasional impact from interstellar dust particles, and the slow heating effects of starlight from distant suns. How does a small body preserve such volatiles over such vast timescales? The most straightforward natural answer involves invoking special formation conditions, or protective mechanisms we don't yet fully understand. Perhaps 3I Atlas formed with an insulating mantle of less volatile material that protects the supervolatile core. Perhaps it formed very recently in cosmic terms, perhaps ejected from its parent system only thousands or millions of years ago, rather than billions, giving it less time to lose volatiles. Perhaps interstellar space is simply more efficient at preserving volatiles than our models predict. All of these represent plausible natural explanations that don't require exotic physics or revolutionary new understanding. But there exists an alternative explanation that's less conventional but potentially fits the data equally well. If 3I Atlas isn't ancient at all, if it wasn't formed billions of years ago, during the primordial epoch of planetary system formation, if it instead represents something manufactured and deployed on timescales relevant to technological civilizations measured in years or decades rather than geological epochs measured in millions of years, then the preservation of supervolatiles becomes trivially easy to explain. A technological artifact wouldn't need to preserve primordial ices across billions of years. It would only need to carry sufficient volatiles to maintain the appearance of cometary activity during its mission duration, which might be measured in mere decades or centuries. This represents the kind of hypothesis that makes most astronomers deeply uncomfortable, not because it's impossible, but because it requires abandoning Occam's razor preference for simpler natural explanations. Yet as one accumulates more and more low-probability observations, at some point the compound probability of all these coincidences occurring naturally becomes lower than the probability of an alternative explanation, however exotic that alternative might seem. We haven't necessarily reached that threshold yet with 3I Atlas, but we're approaching it, and the December observations will potentially tell us whether we've crossed it. Throughout September and early October 2025, as the comet continued its relentless approach toward perihelion, additional observations continued refining our understanding while simultaneously deepening the mystery. Rotation period measurements derived from light curve variations indicated a spin period of approximately 16.16 hours, with brightness fluctuations of about 0.3 magnitudes. This suggests a nucleus that's either slightly elongated or possesses surface features creating brightness variations as different regions rotate into and out of sunlight. The roughly 16-hour period represents relatively slow rotation for a small object, though not impossibly so. Many small bodies in our solar system rotate with similar periods. But this rotation data creates tension with other observations, specifically the Mars spacecraft images showing apparent sunward biased outgassing. That asymmetric activity pattern suggesting more material being expelled toward the Sun than away makes considerably more sense if the nucleus isn't rotating rapidly, if the same hemisphere tends to remain pointed sunward preferentially. How do you reconcile a 16-hour rotation period with observational evidence suggesting nearly tidally locked behavior? You don't, at least not easily with current understanding. Perhaps different observation periods capture different aspects of complex tumbling motion rather than simple rotation. Perhaps the apparent activity asymmetry isn't as strongly sunward biased as preliminary analysis suggested, and will resolve with better data. Perhaps some perfectly reasonable explanation exists that we'll understand once we have more complete observational coverage. Or perhaps something more complicated and less easily explained is occurring that will require new physics or new understanding to properly interpret. As October arrived and 3I Atlas raced toward its date with solar conjunction, the astronomical community found itself in an unusual state of heightened anticipation mixed with genuine uncertainty about what they were actually observing. The evidence supporting a natural, but highly unusual interstellar comet remained strong and compelling. The evidence suggesting something potentially more exotic wasn't definitive, but was substantial enough that dismissing it entirely seemed intellectually dishonest. And precisely at the moment when solar heating should force the object to reveal its true nature most clearly, when perihelion passage should create maximum activity and maximum observational opportunities, it disappeared behind the sun into a multi-week blackout period where no Earth-based instrument could track it. The timing felt almost too perfect, almost surgical in its precision. If you wanted to perform some kind of orbital maneuver without being observed, if you wanted to change trajectory or alter velocity in ways that would reveal artificial intervention, you could not possibly choose a better moment than superior conjunction during perihelion, when every telescope is blind and solar activity makes detection impossible. This is where the speculation becomes both intellectually thrilling and genuinely unsettling for those who take it seriously. Multiple researchers, most prominently Harvard astrophysicist Avi Loeb, have suggested openly that we should seriously consider the possibility that 3I Atlas might represent something technological rather than purely natural. Loeb and his collaborators published calculations demonstrating that if an advanced probe wanted to decelerate from interstellar velocity and enter a bound orbit around our Sun rather than continuing on its hyperbolic escape trajectory back into deep space, the optimal maneuver would be what's called a solar orbit burn. This involves using close perihelion passage to perform high-thrust deceleration at the point of maximum velocity, which maximizes the efficiency of the maneuver through the mathematics of orbital mechanics. And if you wanted to perform such a maneuver without being detected by potentially watchful inhabitants of the system, you would execute it during superior conjunction, when the Sun blocks observation and masks any anomalous acceleration signature. The geometry and timing of 3I Atlas's trajectory aligns perfectly with this scenario, though that by itself proves absolutely nothing since coincidences do occur. But it adds one more item to the accumulating list of improbabilities that collectively strain credulity when you attempt to attribute everything purely to chance. I want to emphasize again with absolute clarity that the vast majority of professional astronomers consider the artificial probe hypothesis extraordinarily unlikely, bordering on implausible. The evidence supporting 3I Atlas as a natural, albeit highly unusual and chemically extreme, interstellar comet remains robust and compelling. Comets exhibit tremendous diversity in composition, structure, and behavior. Objects formed in alien planetary systems orbiting stars with different masses, different metallicities, different radiation environments could easily and naturally display properties we've never encountered before in our limited sample of solar system comets. The extreme carbon dioxide dominance probably indicates formation beyond the carbon dioxide frost line in an unusually cold region of its parent protoplanetary disk. The nickel emission ratios might result from unique mineral compositions in the dust component inherited from the particular mix of materials available in that alien system. The low probability trajectory, while statistically rare, isn't impossible, and in a galaxy containing hundreds of billions of stars constantly ejecting cometary material into interstellar space, even 1 in 20,000 trajectories will occasionally thread through our solar system purely by chance. Occam's razor, that philosophical principle favoring simpler explanations over more complex ones, when both fit the available data, strongly suggests that a natural but exotic comet remains the most likely explanation. We should not abandon that default position without compelling evidence that definitively rules out natural processes. But I also want to emphasize that Occam's razor cuts both directions and applies equally to all hypotheses. If we genuinely inhabit a universe where intelligent technological life has evolved elsewhere among the stars, which seems increasingly likely given the vast number of potentially habitable planets we discovered, and if such civilizations develop the capability for interstellar exploration whether through physical probes or other means, then artificial objects should occasionally pass through our solar system as a simple statistical consequence. The prior probability of encountering such artifacts isn't zero. It's merely unknown because we have insufficient data about the prevalence and behavior of technological civilizations in our galaxy. So while the default assumption should always favor natural explanations for any single observation, we must also remain genuinely open to evidence that might contradict those assumptions and point toward alternative interpretations however exotic they might initially seem. That's what makes the December observations so absolutely critical to resolving this mystery one way or another. When 3I Atlas reemerges from behind the Sun in early December 2025, multiple powerful telescopes will be carefully positioned and fully prepared to capture the first observations the moment it becomes visible again. Ground-based observatories spanning the globe will measure its position with extraordinary subarcsecond precision, carefully comparing the observed trajectory against predictions calculated from pre-perihelion orbital data. Any deviation whatsoever, any unexpected change in velocity, magnitude, or direction, any indication of non-gravitational acceleration beyond what standard cometary outgassing forces can explain, will be immediately and unmistakably apparent in the astrometric measurements. Space-based telescopes, including Hubble and Webb, will examine the object's spectrum and brightness with their unparalleled sensitivity, meticulously searching for any changes in chemical composition, activity level, dust production rate, or structural characteristics that might have occurred during the hidden perihelion passage. If the comet underwent entirely natural and predictable perihelion heating as conventional models expect, these comprehensive observations will definitively confirm that interpretation. The measured orbit will match gravitational predictions perfectly within observational uncertainties. The spectral signatures will show increased outgassing and heightened activity from intense solar heating, then will gradually decrease as expected as the comet moves away from the Sun back toward the outer solar system. Everything will align beautifully with our established understanding of comet physics and chemistry. We'll have discovered an extremely unusual interstellar comet that expands our knowledge of planetary formation conditions in alien systems, which by itself represents a significant scientific achievement worthy of detailed study. But if something else occurred during those hidden crucial weeks behind the Sun, if some kind of maneuver was performed, or if some form of intervention took place that altered the object's trajectory or characteristics in ways that natural heating cannot explain, the December data will expose that unambiguously and unmistakably. We'll observe an orbit that simply doesn't match gravitational predictions, that shows evidence of velocity changes exceeding what cometary outgassing forces could possibly produce by orders of magnitude. We might detect evidence of directed thrust, of attitude changes, of controlled maneuvering that has absolutely no natural explanation. We might witness changes in the object's rotation rate, orientation, or activity patterns that make zero sense for a passive natural body responding purely to solar heating and gravitational forces. And if we observe those kinds of dramatic anomalies, if the accumulated evidence points unambiguously and compellingly towards some form of artificial intervention or technological activity, then absolutely everything changes forever and irrevocably. The global conversation would shift instantaneously from polite academic debate among specialists to existential reckoning involving all of humanity. We would suddenly confront questions that philosophers, scientists, and theologians have contemplated abstractly for centuries, but have never had to answer with immediate practical urgency and real-world consequences. Are we truly alone in the universe, or do we share the cosmos with other intelligences? Are we being studied or surveyed by civilizations far more advanced than our own? Are we safe, or do we face potential threats we cannot yet comprehend? What should humanity do next in response to confirmed contact, even indirect contact through detection of artifacts? How do we communicate or respond if communication is even possible or advisable? These questions would instantly move from the realm of philosophical speculation into the domain of practical policy requiring immediate decisions and coordinated global responses. But we must be patient because we don't yet have those answers. For now, throughout late October and all of November 2025, we exist in this peculiar state of suspended curiosity and enforced waiting, knowing that something potentially significant is happening in that hidden space behind our sun, but remaining completely unable to observe it directly. We wait while 3I Atlas, whatever it fundamentally is, bathes in intense solar radiation at close range, potentially undergoing transformations and changes we cannot measure or monitor. We wait and wonder and speculate, knowing that December will bring answers, but uncertain what those answers will reveal. This represents the very essence of the scientific process at its most honest and transparent. You formulate hypotheses based on available evidence. You design careful observations that can potentially distinguish between competing explanations. You gather data as comprehensively and accurately as possible. And you humbly accept that conclusions must remain provisional and subject to revision as new evidence emerges and understanding deepens. That uncertainty and that intellectual humility aren't failures of science. They represent science functioning exactly as it should, honestly confronting the unknown and resisting the powerful human temptation to claim certainty we don't actually possess. Now let me take you deeper into the October timeline, because that month held additional surprises and strange coincidences beyond just the disappearance of 3I Atlas. Surprises that have left even skeptical scientists shaking their heads in disbelief and wondering if they're witnessing something more significant than random chance. While the comet approached its hidden passage behind the sun, Earth itself found itself caught in an unprecedented barrage of solar activity that felt almost coordinated in its timing and intensity. Between October 16th and October 21st, 2025, our planet endured multiple powerful M-class solar flares erupting from a rapidly growing and highly active sunspot group that had rotated into geoeffective position facing directly toward Earth. Each explosive flare was more powerful than the last, releasing enormous quantities of electromagnetic radiation and high-energy particles. 3 separate massive coronal mass ejections launched from the sun's surface in quick succession, each one carrying billions upon billions of tons of magnetized plasma across the 93 million-mile gulf of space separating Earth from the sun, all aimed directly at our planet's magnetic field. NOAA's Space Weather Prediction Center issued a G2-level geomagnetic storm warning, then quietly upgraded their internal forecasting models, as incoming data showed the impacts would likely be substantially stronger than initial predictions suggested. And positioned right in the temporal middle of this intense solar assault, precisely as Earth's protective magnetic field buckled and flexed and compressed under the relentless onslaught of charged particles, 3I Atlas reached superior conjunction with the Sun during the new moon phase when Luna itself was invisible. The timing made a lot of people nervous, even those who don't typically subscribe to notions of cosmic synchronicity or meaningful celestial alignments. Let me paint this picture more clearly and comprehensively, so you understand exactly what transpired. Solar flares, by themselves, are not particularly unusual phenomena. Our Sun goes through a well-documented 11-year cycle of magnetic activity, and we're currently approaching solar maximum, the peak activity phase of cycle 25. During these active periods, sunspot groups form and dissipate regularly as magnetic field lines beneath the visible surface tangle and twist and eventually snap, releasing accumulated energy in spectacular bursts of radiation spanning the entire electromagnetic spectrum and accelerating particles to enormous velocities. We expect this elevated activity. We monitor it continuously with dedicated spacecraft. We have entire government agencies dedicated specifically to space weather forecasting and prediction. But the specific sequence and timing of events during mid-October 2025 stood out as unusual even against the background of an active solar maximum. The sunspot group that spawned the series of powerful flares grew extraordinarily rapidly, expanding to several times Earth's diameter within just a few days rather than the week or more that's more typical. It rotated into geoeffective position, meaning it faced directly toward our planet with perfect alignment, virtually guaranteeing that any eruptions would strike us squarely rather than missing Earth or delivering only glancing blows. And it didn't stop flaring. Day after day, the active region continued producing significant eruptions, with a persistence that exceeded typical patterns. October 16 saw the first major eruption, a substantial M-class flare that sent intense ultraviolet and X-ray radiation streaming toward Earth at the speed of light, arriving just 8 minutes later. Radio operators worldwide noticed sudden disruptions and signal degradation. Satellite controllers logged various anomalies and glitches in spacecraft systems. Nothing catastrophic or civilization-threatening occurred, but the effects were noticeable and measurable across multiple technological systems. Then came the coronal mass ejections, the slower-moving but potentially far more dangerous component of solar storms in terms of their effects on Earth's magnetic environment and technological infrastructure. These truly massive clouds of magnetized plasma take between 1 and 3 days typically to traverse the immense distance between Sun and Earth depending on their initial velocity. Space weather forecasters carefully track 3 distinct CMEs, each one following slightly different trajectories through interplanetary space, but all converging on our planet's location within a remarkably narrow time window. October 19th brought the first impact. October 20th brought the second. October 21st brought the third and most powerful impact, arriving just hours before the new moon and just hours before 3I Atlas slipped behind the solar disk into the observation blackout. When the magnetized plasma cloud struck Earth's magnetosphere in succession, the effects were dramatic and widespread. Earth's protective magnetic field compressed significantly, with field lines that normally extend tens of thousands of miles into space being pushed back much closer to the planet's surface by the pressure of the impacting solar wind. Spectacular auroras danced across the night sky at unusually low latitudes, visible as far south as the northern United States and throughout Central Europe, treating millions of people to a celestial light show they normally never experience at their geographic locations. But the visible auroral displays, as beautiful and dramatic as they appeared, represented merely the surface manifestation of deeper and more significant changes occurring in Earth's magnetosphere and radiation environment. Earth's radiation belts, those toroidal donut-shaped regions of trapped high-energy particles surrounding our planet in space, became dramatically supercharged with incoming energetic particles. For approximately 1 week leading up to October 13th and 14th, monitoring satellites recorded radiation belt particle flux at extraordinarily high levels, well above normal background and exceeding anything measured in months. Then on October 13th and 14th, just days before the main impacts, something called an ion precipitation event occurred. The trapped energetic particles suddenly dumped from the radiation belts into the upper atmosphere, releasing their accumulated energy in a massive cascade that rippled through the entire magnetospheric system. And immediately following that sudden energy release, two significant earthquakes struck in different parts of the globe. A magnitude 6.5 earthquake occurred near Papua New Guinea. A magnitude 6.3 earthquake struck in the Drake Passage near Antarctica. Both events registered on October 16th, precisely as the solar activity was intensifying toward its peak. Now, I absolutely must be extremely careful and precise here because the potential connection between solar activity and seismic events remains highly controversial and largely rejected in mainstream geophysics. The standard well-established view holds that earthquakes result primarily from tectonic stress accumulation and sudden release driven by the slow grinding of crustal plates over geological timescales. This process operates according to mechanical forces and material properties of rocks deep beneath Earth's surface. Solar storms, by contrast, occur on timescales of hours to days, and involve primarily electromagnetic energy and charged particles, not direct mechanical force applied to crustal plates. There exists no widely accepted physical mechanism by which a coronal mass ejection occurring in space 93 million miles away could directly trigger an earthquake deep within Earth's crust. The energy densities are wrong, the force mechanisms are incompatible, the physics doesn't obviously connect. And yet, researchers like geophysicist Stephen Burns, who has been meticulously tracking these kinds of correlations for years, keep finding persistent statistical patterns that are difficult to dismiss as pure coincidence. Ion precipitation events followed within hours, or days, by major seismic releases. Periods of unusually low solar wind density coinciding with statistical upticks in the frequency of high-magnitude earthquakes. Certain configurations of Earth's magnetic field correlating with slightly elevated seismicity. These patterns appear repeatedly in the data, though the effect sizes are small, and the mechanisms remain completely unclear. It's not proof of causation. It's not even particularly strong statistical evidence by rigorous scientific standards, given the multiple comparisons problem and the possibility of data mining artifacts. But the patterns are persistent enough across different datasets and different analysis methodologies that some researchers believe we might be missing something important about how energy flows through interconnected geophysical systems. Perhaps charged particles precipitating into the atmosphere create electromagnetic effects that couple to Earth's crust through mechanisms we haven't identified. Perhaps there are subtle but real connections between electromagnetic field variations and stress states in crustal rocks that modern geophysics hasn't yet recognized. Or perhaps the apparent correlations are entirely spurious, arising from random chance combined with human pattern-seeking psychology seeing connections where none exist. We genuinely don't know, and mainstream geophysics remains highly skeptical pending much stronger evidence and a plausible physical mechanism. The October sequence nevertheless fit the pattern that Burns and others have been documenting. Radiation belts became supercharged with energetic particles. Sudden discharge and precipitation occurred. Major earthquakes struck within hours of that discharge. And then, as if cosmically coordinated, another powerful punch to the magnetosphere arrived from the incoming coronal mass ejections, recharging the radiation belts to high levels again and potentially setting up the system for another release cycle. The timing alignment with 3 Atlas reaching superior conjunction during a new moon might be completely meaningless. Space weather phenomena and comet orbital mechanics operate according to entirely different physical principles, with no obvious causal connection. But humans are fundamentally pattern-seeking creatures. We've evolved to detect patterns because that ability provided survival advantages. And when multiple unusual events cluster together temporally, even if they're causally independent, we cannot help but wonder if they share some hidden connection or common cause we haven't yet identified. Then we must consider the magnetic field situation, which has been quietly growing stranger for years, but reached a notable documented milestone in October 2025 that added another layer of strangeness to an already strange month. The European Space Agency released comprehensively updated data from their Swarm satellite constellation, a trio of spacecraft continuously monitoring Earth's magnetic field with unprecedented precision, showing in detail how our planet's magnetic field has evolved and changed from 2014 through 2025. The results were genuinely striking to geophysicists who study these phenomena. The South Atlantic anomaly, that mysterious region centered off the coast of Brazil where Earth's magnetic field is unusually and significantly weak compared to global averages, has expanded dramatically in geographic extent over just 11 years. The anomaly has grown by an area roughly equivalent to the entire landmass of Western Europe, a truly enormous change occurring on a timescale of just 1 decade rather than the centuries or millennia typical for major geomagnetic changes. The magnetic field strength within that region has dropped by 330 nanotesla, representing a very significant decrease that has practical implications for satellite operations and radiation exposure. At the same time, other features of Earth's complex magnetic field have shifted substantially. The magnetic flux lobe centered over Siberia, where field strength is higher than the global average, has increased by approximately 250 nanotesla, partially compensating for the weakness in the South Atlantic. The flux lobe over Canada has weakened dramatically by more than 800 nanotesla, reshaping the entire high-latitude field configuration. These are absolutely not trivial changes or minor fluctuations within normal variation. They represent a magnetic field in dramatic flux, literally and figuratively, undergoing changes whose ultimate implications remain unclear. The South Atlantic anomaly matters enormously because it represents the location where Earth's protective magnetic shield is weakest and least effective. Cosmic radiation and high-energy particles from the Sun, normally deflected efficiently by the magnetic field before they can penetrate into the atmosphere, can penetrate much deeper in this region, where the field strength is insufficient to provide complete protection. Satellites passing through the South Atlantic anomaly experience dramatically higher rates of electronic glitches, memory errors, and component failures due to particle strikes. The International Space Station, when its orbit carries it over the anomaly region multiple times daily, exposes astronauts to measurably increased radiation doses that must be carefully monitored and managed to avoid exceeding safety limits. And now this region of weakness is actively expanding eastward, reaching progressively towards South Africa and potentially beyond, growing in both geographic size and intensity of the magnetic field deficit. It's not an immediate crisis threatening civilization or requiring emergency response, but it represents a long-term trend that nobody fully understands or can predict with confidence. Some sophisticated computer models suggest this might represent the early stages of a full magnetic pole reversal, a dramatic event where Earth's north and south magnetic poles flip positions. Such reversals occur somewhat regularly on geological timescales, happening on average every few 100,000 years, and the last one occurred approximately 780,000 years ago. From a purely statistical perspective, we're arguably overdue for another reversal, though the timing is sufficiently irregular that overdue doesn't necessarily mean much. Other equally sophisticated models suggest the South Atlantic anomaly represents merely a normal fluctuation, a temporary wobble in the complex geodynamo system that generates Earth's magnetic field through convection of liquid iron in the outer core, and will eventually correct itself and stabilize without progressing to a full reversal. Nobody knows with certainty which interpretation is correct, though monitoring continues and models gradually improve. What we do know with absolute certainty is that during the October 2025 solar storm sequence, when those three powerful coronal mass ejections struck Earth in rapid succession, this weakened region of our magnetic field got absolutely pummeled by charged particles that penetrated deeper than they normally could. More cosmic radiation than typical made it through to the upper atmosphere in this region. More energy dumped into the magnetospheric system. More stress placed on the already weakened and rapidly changing magnetic configuration. And all of this occurred while the northern magnetic pole continued its steady and well-documented march from its historical location in Canadian Arctic territories toward Siberia, accelerating from its historical drift rate of about 10 kilometers per year maintained for centuries to its current rapid pace of roughly 40 kilometers per year. The magnetic field is demonstrably moving, shifting, changing. The anomalies are growing and intensifying. And we hit this already dynamic system with three powerful coronal mass ejections during the exact week that three Atlas disappeared behind the Sun during a new moon phase. The coincidental timing is almost poetic in a strange cosmic way that makes even hardened skeptics pause momentarily. Some observers, particularly those more attuned to energetic, metaphysical, or astrological interpretations of celestial events, perceive the October 2025 convergence as deeply and profoundly significant from an esoteric perspective. The new moon traditionally represents new beginnings in many cultural and astrological traditions, a cosmic reset, a clearing of the slate, an opportunity for fresh starts and new directions. Superior conjunction, where an object aligns directly with the Sun from Earth's perspective, theoretically amplifies that object's energetic influence according to astrological principles, creating powerful symbolic resonances that some believe can manifest in physical reality or human consciousness. The constellation Virgo, where this celestial alignment occurred, carries profound associations across multiple cultural traditions with themes of purity, transformation, harvest, hidden knowledge gradually revealed, and transitions between states of being. When you layer on top of that symbolic foundation the intense and unprecedented solar activity battering Earth's magnetosphere, the magnetic field perturbations reshaping our planet's protective shield, the seismic releases occurring in precise temporal correlation with radiation belt discharges, you create what some observers describe as a recipe for something cosmically important, even if articulating exactly what that importance means proves elusive. I want to be absolutely clear and transparent that I'm not here to validate or dismiss those more esoteric interpretations of celestial events. My purpose is to note objectively that multiple genuinely independent phenomena, operating according to different physical time scales, and through fundamentally different causal mechanisms, all reach peak intensity or significant transition points within a remarkably narrow window of just a few days in mid to late October 2025. That temporal clustering represents an observable fact independent of any interpretive framework. What it means, if it means anything beyond statistical coincidence, if it carries significance beyond the random fluctuations we should expect in a complex chaotic universe, remains entirely open to individual interpretation informed by personal worldviews and philosophical frameworks. But let's return our focus to more concrete and scientifically testable questions. Could the intense solar activity that battered Earth during this period have also affected 3I Atlas as it passed through perihelion? Could the same coronal mass ejections that compressed our magnetosphere and triggered auroral displays also have interacted significantly with the comet? The answer is unambiguously yes. Almost certainly those interactions occurred. Solar storms don't selectively affect only Earth, while leaving other objects in the solar system untouched. They propagate as expanding bubbles throughout the entire inner solar system and beyond. When a coronal mass ejection erupts explosively from the Sun's surface, it carries with it an expanding bubble of enhanced magnetic field embedded in hot dense plasma along with accelerated high-energy particles that stream outward at speeds typically ranging from several hundred to over 1,000 kilometers per second. As this enormous bubble sweeps radially outward from the Sun, expanding and gradually dissipating, it passes planets, asteroids, comets, spacecraft, and any other objects in its path, potentially causing various measurable effects depending on the nature of each object. For active comets with substantial comas and tails, the passage of a coronal mass ejection can cause dramatic visible effects. The comet's tail can get pushed around and distorted as the enhanced magnetic fields and particle flux interact with the ionized gas. Dust particles suspended in the coma experience additional forces from the increased particle bombardment. The sublimation rate might even change slightly as the enhanced particle flux delivers additional energy to the nucleus surface. These effects have been observed and documented numerous times when comets happen to be well positioned for observation during major solar storms. For a comet sitting at 1.36 astronomical units from the Sun during its perihelion passage, positioned right in the heart of the inner solar system, where solar wind and radiation are most intense, the October 2025 solar storms would not have been gentle or negligible. The three powerful coronal mass ejections that struck Earth would have struck 3I Atlas as well, possibly with even greater intensity depending on the exact geometries, and whether the comet happened to be positioned more directly in line with the eruption source regions. Now, would those storm effects be dramatic enough to fundamentally alter the comet's behavior or reveal hidden properties? Almost certainly not if we're discussing a natural comet. Solar storms carry enormous energy on human scales, but remain relatively weak when it comes to moving massive solid objects through space or fundamentally altering their trajectories. Even if 3I Atlas has a nucleus only a few kilometers across, representing the smaller end of the size estimates, it still possesses enough mass and momentum that a coronal mass ejection would barely nudge it gravitationally. The increased particle flux might enhance coma brightness slightly for a few hours or days, as enhanced heating drives additional sublimation. The distribution of dust in the coma might get temporarily disturbed or pushed into different configurations. But these represent subtle effects, secondary details that wouldn't fundamentally change our understanding of what we're observing. If 3I Atlas is a natural comet composed primarily of primordial ice and rock, the October solar activity would not have changed its essential nature or behavior in detectable ways. However, if the comet represents something other than a purely natural object, if it contains instrumentation or sensors designed to monitor and record environmental conditions, those instruments would have registered the solar storm passage as a significant event worth detailed analysis. An artificial probe passing through an alien star system during a period of heightened stellar activity would want to collect comprehensive data about how that star behaves during active phases. Measurements of stellar wind variations, magnetic field fluctuations, and reconnection events, particle fluxes and energy spectra, radiation levels across multiple wavelengths would provide invaluable scientific intelligence about the star's behavior and about conditions any planets in that system experience regularly. This perspective leads to an uncomfortable realization that some researchers have noted. If you were designing a scientific mission to study another stellar system comprehensively, you would deliberately want your probe to arrive during an active period rather than during the star's quiet phase. Arriving during stellar minimum, when the star is magnetically quiet and boring, would teach you far less than arriving during stellar maximum, when dynamic processes are operating, when you can measure the full range of variability and intensity that defines that star's behavior, and that any potential life in that system would need to adapt to surviving. And if you possessed really sophisticated mission planning and execution capabilities, if you commanded technology allowing precise trajectory control and timing, you might attempt to schedule your perihelion passage to coincide with a period of elevated stellar activity, deliberately maximizing your data collection opportunities during the brief window when your instruments are closest to the energy source and measurements would be most valuable. The October convergence, when viewed through that particular interpretive lens, appears less like random coincidence and more like careful planning and coordination. I want to emphasize again that I'm not asserting this is what actually happened. I'm outlining a hypothesis that some researchers in the astronomical community have proposed, a possibility that fits the observed data while requiring us to accept some extraordinary assumptions about the prevalence and capabilities of extraterrestrial technology. The hypothesis remains speculative, and most astronomers would argue it's unnecessarily exotic. But it's worth understanding the logic and seeing how the pieces could fit together if those extraordinary assumptions prove correct. We also cannot ignore the human element and the psychological dimension of how people responded to the October convergence. The effects weren't limited to instruments and magnetic fields and geological processes. They extended to human beings themselves, to biological organisms living within Earth's electromagnetic environment. During periods of intense solar activity and geomagnetic storms, medical researchers and epidemiologists have documented various statistically significant correlations with human health outcomes. Reports of disrupted sleep patterns and insomnia spiked during major geomagnetic storms. Emergency room visits for cardiac events, including heart attacks and arrhythmias, show small but measurable increases. Incidences of migraine headaches rise. Some studies have even found correlations with psychiatric hospital admissions and behavioral changes, though these effects remain controversial, and not all studies replicate the findings. The mechanisms underlying these biological effects remain debated and incompletely understood, but the correlations exist consistently enough in the medical literature that they warrant serious scientific attention. Our bodies are fundamentally electromagnetic systems operating within an electromagnetic environment. We have iron-containing hemoglobin circulating continuously through our blood vessels. We possess trace minerals, including magnetic-sensitive materials, distributed throughout our tissues. Our neurons communicate through electrical signals. Our hearts beat according to electrical pacemaker rhythms. Our brains generate measurable electromagnetic fields that can be detected with sensitive instruments. We are not isolated from the electromagnetic environment surrounding us. We are embedded within it, constantly interacting with it, responding to its fluctuations even when we don't consciously register those responses. When that electromagnetic environment shifts dramatically during a major geomagnetic storm, when Earth's magnetic field compresses and oscillates, when charged particle fluxes increase by orders of magnitude, when Schumann resonances in Earth's ionosphere change frequency and amplitude, we feel those effects at some level. The responses might be subtle, might operate below conscious awareness, might vary significantly between individuals based on genetic factors and health status. But the responses exist and can be measured if you know what to look for, and how to design studies that properly control for confounding variables. And throughout mid-October 2025, as the solar storms progressively intensified, as the magnetic field buckled under repeated coronal mass ejection impacts, As the new moon phase erased the night sky and 3I Atlas slipped silently out of view behind the solar disk, millions of people around the world reported subjective experiences of feeling unsettled, restless, anxious without clear cause, sensing that something significant was about to change or shift in ways they couldn't articulate clearly. Sleep quality declined for many. Dreams became more vivid or disturbing. Emotional states fluctuated more than usual. Maybe all of those subjective reports simply reflected the direct biological effects of the geomagnetic storms, our bodies responding to environmental changes through mechanisms we're only beginning to understand. Maybe the feelings of unease stemmed from collective anxiety amplified and spread through social media connectivity, where billions of people can share feelings and experiences instantaneously, creating feedback loops of emotional contagion. Maybe the sense that something important was happening arose from cognitive biases and our human tendency to create meaning and pattern from random events, especially when unusual occurrences cluster together temporally. Or maybe, just possibly, we were collectively detecting something our instruments hadn't yet confirmed, picking up subtle signals through channels we don't consciously recognize or scientifically understand yet. The geophysicist Stephen Burns, who has built his research career tracking these kinds of correlations between cosmic events and terrestrial phenomena, captured this moment beautifully in his analysis of the October convergence period. He meticulously documented the sequence of events unfolding like dominoes falling in carefully timed succession. The radiation belts becoming charged to extraordinarily high levels with energetic particles trapped from previous solar activity. The sudden discharge event, as those particles precipitated into the atmosphere releasing accumulated energy. The magnitude 6+ earthquakes occurring within hours of that energy release in geographically distant locations. The incoming high-speed solar wind stream carrying the coronal mass ejections that would recharge the system. The new moon occurring in precise temporal alignment, with 3I Atlas reaching superior conjunction with the Sun. He observed this confluence of independent processes reaching critical points simultaneously and suggested, with careful scientific caution blended with genuine wonder and appropriate humility, that October 21st represented a powerful energetic moment in some deeper sense that conventional reductionist science might not fully capture. His recommendation to his audience and followers was remarkably grounded and practical rather than mystical or escapist. Practice enhanced self-care during this period. Spend additional time in nature if possible. Prioritize rest and sleep. Create space for quiet reflection. Monitor your emotional states with compassionate awareness. He wasn't embracing astrology or metaphysical mysticism. He was recognizing pragmatically that human beings respond to their environment in complex ways we don't fully understand yet, and that extraordinary environmental conditions call for mindful attention to our own well-being and conscious choices about how we navigate unusual circumstances. It represented an admirably balanced response to extraordinary events, acknowledging their unusual nature without manufacturing unwarranted certainty about their meaning or implications. We're now temporally past that convergence point as I record this presentation. The solar storm activity has subsided back to normal background levels typical of solar maximum. Earth's magnetic field has returned to its baseline state of slow drift and quiet anomalies gradually evolving over years and decades. The new moon has progressed through its cycle. 3I Atlas continues its hidden journey behind the Sun, currently experiencing whatever transformations occur during intense solar heating at close range, completely unobserved by any Earth-based or Earth orbital instrument. But the fundamental questions raised by the October convergence remain unanswered and unresolved. Did anything genuinely significant happen during those crucial days beyond the expected physical processes? Did our mysterious interstellar visitor respond to the solar barrage in unexpected ways that will become apparent in December observations? Will the post-perihelion measurements reveal changes we cannot yet imagine or predict? Or was October 2025 simply a statistically unusual, but ultimately meaningless clustering of independent events? Exactly the kind of thing that must occasionally occur in a sufficiently complex and chaotic universe given enough time? We won't know with certainty until the comet reemerges from behind the Sun in early December and telescopes can resume observations. Until then, we exist in this peculiar state of suspended curiosity mixed with enforced patience, knowing that something potentially important might be happening in that hidden space, while being completely unable to observe it directly or measure it quantitatively. This captures the essence of the scientific process at perhaps its most honest and transparent level. You formulate hypotheses based on available evidence and theoretical understanding. You design careful observations that can potentially distinguish between competing explanations and rule out alternatives. You gather data as comprehensively and accurately as your instruments allow. And you humbly accept that conclusions must remain provisional, subject to revision as new evidence emerges, as understanding deepens, as better theories develop that explain more of the observations more simply. That uncertainty, that intellectual humility, that willingness to say, "We don't know yet, but we're working to find out," represents science functioning exactly as it should. It's not a failure or weakness. It's the core strength that allows science to eventually converge on truth through iterative refinement, even when individual scientists hold competing views and favor different hypotheses. The December observations of 3I Atlas emerging from behind the Sun will provide that crucial next iteration of evidence that moves us closer to understanding what we've actually been observing. Now let me take you deeper into the details of what those Mars observations revealed, because some of those details are genuinely fascinating and add important pieces to this complex puzzle we're attempting to solve. When the European Space Agency's Mars orbiter successfully photographed 3I Atlas on October 3 during the comet's closest approach to the red planet, the technical achievement alone deserves celebration and recognition. These spacecraft carry cameras and spectrometers specifically designed and optimized for studying Mars itself, for photographing surface features from orbit, and analyzing atmospheric composition. The instruments were never intended for observing faint astronomical objects millions of miles away against the background star field. The sensitivity is wrong for that application, calibrated for bright planetary surfaces rather than dim point sources. The pointing requirements are completely different, requiring the spacecraft to slew away from Mars and hold steady aim at a moving target for extended exposure times. The data rates and storage capacities were designed around planetary observations, not astronomical surveys. That these missions managed to capture any useful data at all about 3I Atlas represents impressive creativity and technical capability on the part of mission planning teams who found ways to use their spacecraft in modes never anticipated during the design phase decades earlier. The images themselves, after extensive processing to remove noise and enhance faint signals buried in the detector readout, showed exactly what you'd hope to see: confirmation that 3I Atlas was precisely where orbital predictions said it should be at that moment. This provided critical validation of the trajectory calculations and confirmed the comet was following a gravitationally determined path without obvious deviations. The object appeared as a diffuse smudge rather than a point source, confirming continued cometary activity with an active coma surrounding the nucleus. The coma extended visibly for thousands of kilometers in the processed images, though measuring its precise extent proved challenging given the faintness and the limitations of instruments not designed for this kind of work. But beyond those basic confirmations that checked necessary boxes, the images revealed something genuinely unexpected and potentially quite significant. The coma exhibited clear asymmetry rather than the roughly circular symmetric shape you'd expect from uniform sublimation from a rotating nucleus. Material extended preferentially in certain directions, creating an elongated teardrop appearance rather than a spherical cloud. Now, asymmetric comas are absolutely not unusual in comets. In fact, they're extremely common because cometary nuclei are irregularly shaped rotating bodies covered with active regions concentrated in specific areas determined by composition variations and structural features. As the nucleus rotates, different patches face the Sun at different times throughout the rotation period, creating jets and plumes that push material outward in preferred directions that change as rotation continues. So observing coma asymmetry by itself wouldn't normally warrant particular attention. It's expected, it's standard, it's what we see routinely. What caught the attention of researchers analyzing these Mars images was the specific geometry and orientation of the asymmetry. The enhanced outgassing and denser coma material appeared to favor the sunward direction, meaning more material was being pushed toward the Sun than away from it. This represents a backwards configuration from what you typically observe in cometary comas and tails. Normally intense solar radiation pressure and the fast-moving solar wind consisting of charged particles push cometary material away from the Sun, always away regardless of the comet's motion direction. That's why comet tails always point away from the Sun even when the comet is moving away from the Sun after perihelion, creating the initially counterintuitive situation where sometimes the tail leads and the nucleus follows. This outward push creates the iconic appearance we associate with comets throughout history. But 3I Atlas, based on these Mars orbital images, seem to be preferentially puffing material toward the Sun rather than away, or at minimum showed much more symmetry in the sunward and anti-sunward directions than conventional models predict. The August observations from the Keck telescopes had already hinted at this unusual pattern. The distribution of nickel and cyanide emissions visible in those ground-based spectroscopic observations showed a sunward bias that seemed strange. The October images from Mars orbit now confirmed that this pattern persisted and perhaps even strengthened as the comet approached closer to perihelion. Natural explanations exist for this kind of behavior if you're willing to invoke specific conditions. If the nucleus rotates very slowly, or perhaps doesn't rotate significantly at all, if it's tidally locked or tumbling in some complex way that keeps one hemisphere preferentially pointing sunward, then all the sublimation and outgassing would occur predominantly from the sunward-facing day side, while the night side remains cold and inactive. All the liberated gas and dust would initially move outward from the sunward hemisphere in that direction, before the solar wind eventually catches it and sweeps it back into a more traditional configuration farther from the nucleus. This represents a reasonable and physically plausible model that doesn't require exotic physics or revolutionary new understanding. It fits the observations if you accept certain assumptions about the rotation state. But it requires some specific and somewhat unusual conditions. Slowly rotating or non-rotating nuclei are relatively uncommon because objects tumbling through space for billions of years tend to be spinning due to accumulated angular momentum from countless gravitational interactions and occasional impacts they've experienced over cosmic timescales. Most comets we observe spin with periods ranging from hours to days, creating systematic variations in activity and brightness as different regions rotate into and out of sunlight. Finding an object that doesn't spin much, or that spins so slowly it might as well not be rotating on relevant timescales, requires special circumstances we don't encounter frequently. Perhaps 3I Atlas experienced some collision or close gravitational encounter relatively recently in cosmic terms that damped its rotation. Perhaps it formed with low angular momentum through formation processes we don't fully understand. Perhaps there's something about its internal structure or mass distribution that affects its rotation in unexpected ways. All of these scenarios remain possible and would preserve a natural explanation for the observed behavior. But there exists an alternative interpretation that some researchers have noted, usually privately in conversations over coffee rather than in formal publications. If 3I Atlas isn't a natural comet at all but rather represents some form of technological artifact, then many of the puzzling observations would make more sense or at least require fewer special case assumptions. An artificial object wouldn't necessarily rotate unless rotation served some functional purpose. It might maintain a fixed orientation relative to the Sun for thermal management reasons, or to keep solar panels or radiators properly positioned. It might actively control its attitude using reaction wheels or thrusters. The asymmetric outgassing could represent deliberate venting of material in specific directions rather than passive sublimation driven purely by solar heating. The chemical composition could be engineered rather than primordial, optimized for creating the appearance of cometary activity while serving other functions. I want to emphasize that this remains highly speculative thinking, the kind of what-if reasoning that explores logical possibilities without necessarily claiming they represent reality. Most astronomers would argue such speculation is premature and unwarranted given that natural explanations remain viable. But the speculation exists in the community, more widely discussed than publicly acknowledged, because the accumulating anomalies have reached a density that makes thoughtful researchers at least consider alternatives they might otherwise immediately dismiss. The European Space Agency in their official public statements regarding the Mars observations was appropriately cautious and measured in their language and conclusions. They described the observations as scientifically successful, providing valuable data about an interstellar object from a unique vantage point that Earth-based telescopes cannot access. They noted the technical challenges that were overcome to capture these images of such a faint target. They emphasized that full detailed analysis of the data was ongoing, and that preliminary interpretations should be treated as tentative pending more complete study and peer review. When pressed by science journalists seeking more provocative statements or dramatic quotes, ESA spokespersons emphasized that comets are diverse objects exhibiting wide variation in properties, and that unusual features don't necessarily indicate anything beyond that natural diversity. Translation from diplomatic scientific language into plain English. We observed something interesting that doesn't perfectly match simple models. We're not entirely sure what it means yet. We're not going to speculate wildly or make extraordinary claims without extraordinary evidence to support them. This represents exactly the appropriate response from a responsible scientific organization when dealing with extraordinary observations and limited data. But that measured, cautious response also left a gap, an interpretive vacuum that speculation and alternative hypotheses rush to fill in social media discussions, YouTube videos, podcasts, and online forums where the conversation is less constrained by institutional caution. And that speculation has flourished and multiplied over the weeks since those observations occurred, fed by the genuine strangeness of what we're observing, and by the knowledge that the most critical observation window occurred during the solar conjunction blackout, when we couldn't see anything at all. NASA's participation in the Mars observation campaign adds another intriguing element to this story, one that has generated its own speculation and questions. The Mars Reconnaissance Orbiter, one of NASA's most capable spacecraft currently operating at Mars, carries an extraordinarily powerful camera system called HiRISE, the High-Resolution Imaging Science Experiment. This camera can resolve features on the Martian surface down to approximately 30 centimeters, capturing detail fine enough to identify individual boulders and to track seasonal changes in surface features across multiple Martian years. When pointed at the sky rather than downward at the surface, HiRISE could theoretically capture substantially more detail about 3I Atlas than the European orbiters managed, potentially resolving structure in the coma or even glimpsing the nucleus itself if conditions were favorable. NASA announced publicly that they would attempt observations of the comet using Mars Reconnaissance Orbiter during the October approach. They confirmed through mission status updates that the spacecraft successfully executed the necessary pointing maneuvers and acquired data during the planned observation windows. And then, nothing. No images released to the public or the scientific community. No official statements about whether the observation succeeded or failed technically. No data published in any accessible form that independent researchers could analyze. No press releases celebrating a successful observation of an historic interstellar visitor. Just silence and the absence of information where you'd normally expect transparency and data sharing. This pattern is unusual enough to warrant comment and has generated various theories attempting to explain it. The most straightforward and probably correct explanation is simply that spacecraft operations are genuinely complex undertakings with many competing priorities. Data processing requires significant time and human effort. Mission teams must balance multiple demands on their resources. HiRISE generates enormous data volumes that must be carefully processed and calibrated before they're scientifically useful. The observation might have failed for any number of technical reasons: pointing errors, timing problems, detector issues, data transmission glitches. And NASA is under no obligation to immediately release every observation, especially if the data quality is poor or the scientific value is limited. So perhaps we're simply waiting for normal processing timelines to complete, and eventually the HiRISE observations will appear in the public archive once teams have time to work through their backlog. This explanation requires no conspiracy, no cover-up, no exotic reasoning. Just normal operations under resource constraints. It's probably correct. But the absence of any communication about the observations, even just acknowledging they're being processed and will be released when ready, has fueled alternative speculation. Some observers wonder if the HiRISE observations revealed something unexpected that requires careful review and analysis before release. Perhaps the images show coma structure or features that don't match models and need to be verified independently before making claims. Perhaps there's concern about misinterpretation or about fueling unwarranted speculation if images are released without proper context. Perhaps institutional caution is delaying release until all the relevant stakeholders agree on how to present and frame the findings. Again, this wouldn't indicate anything necessarily suspicious or sinister, just organizational dynamics and risk management operating as they normally do in large institutions. Down on the Martian surface, the Perseverance and Curiosity rovers faced essentially impossible challenges in attempting to photograph 3I Atlas. These mobile science laboratories carry sophisticated camera systems, but those systems are specifically designed for close-range geology and terrain imaging, not for astronomical observations of faint objects millions of miles away. The camera sensors lack the sensitivity for long exposures of dim astronomical targets. The pointing precision isn't designed for tracking objects across the star field. The data storage and transmission systems prioritize geological and atmospheric data over speculative astronomical observations that have low probability of success. That both rovers attempted observations anyway speaks to the intense interest in 3I Atlas, and to the willingness of mission teams to be creative and opportunistic with their assets. Whether those observations succeeded in capturing anything scientifically useful remains unclear. Rover data downloads follow strict priority queues, where the most urgent and valuable science observations get transmitted first. Speculative astronomical images that might show nothing but noise would naturally rank low in those priorities. If useful images exist somewhere in the rover's memory systems or in the massive data archives waiting for processing, it might be months before anyone retrieves and examines them. So we are left with these partial glimpses, these fragments of observations that raise more questions than they answer definitively. The European orbiters confirmed 3I Atlas was active and showed asymmetric outgassing favoring unexpected directions. NASA's most capable Mars orbiter attempted observations, but has released nothing publicly. The surface rovers tried against all odds, but probably didn't capture anything useful. And then the comet slipped behind the sun, where no instruments could follow, entering the blackout period that continues until December. The frustration in the astronomical community is palpable and understandable. They've devoted months of precious telescope time and effort to studying this object. They've discovered extraordinary chemical anomalies that challenge our understanding of interstellar comet composition. They've documented unusual activity patterns and trajectory coincidences that strain statistical credulity. They've watched it approach the most critical observation period, when perihelion heating should reveal its true nature most clearly. And then at precisely that critical moment, geometry and celestial mechanics conspired to hide the object from view for weeks during the exact window when the most important changes should be occurring. If you were writing fiction, if you were crafting a mystery thriller about cosmic enigmas, you could not possibly design better dramatic timing. The universe, it seems, has a finely developed sense of suspense and narrative pacing. Before we move forward toward anticipating what the December observations might reveal, I need to pause here and make sure you're still engaged with this content, because we're approaching a critical juncture in the presentation. If you've stayed with me this far, if you're genuinely invested in understanding this mystery as it unfolds in real time, I need you to take 3 specific actions right now. First, hit that like button if you haven't already done so. Your like sends a signal to the platform's algorithm that this content is valuable and engaging, that viewers want substantive scientific analysis rather than shallow sensationalism. Every like genuinely helps the channel grow and reach more people who appreciate this approach to cosmic mysteries. Second, subscribe to this channel and enable all notifications. December is rapidly approaching. When 3I Atlas reemerges and new observations arrive, when we finally get answers to the questions we've been exploring, you'll want to be among the first to see the detailed analysis and understand what the data reveals. I'll be creating comprehensive follow-up content breaking down exactly what the measurements show, what they mean, and what implications they carry. Third, and most important for building community engagement, leave a comment right now. Everyone who makes it to this point should write exactly these 3 words. December will decide. This creates a public time-stamped record of our collective anticipation, documenting this unique moment of uncertainty before the observations that will resolve it. When we look back after December, these comments will represent a fascinating historical record of what we were thinking and feeling before we knew the answers. And then after you've done those 3 things, after you've liked and subscribed and commented, click on the next video appearing on your screen right now. Continue exploring the cosmos with me. Continue investigating the mysteries hiding in the spaces between what we know and what we've yet to discover. There are more wonders waiting, more questions demanding investigation, more evidence of just how strange and surprising our universe truly is when you look carefully enough and ask the right questions. The universe is vast beyond human comprehension, containing structures spanning billions of light years and phenomena operating on timescales from the briefest quantum fluctuations to the age of the cosmos itself. We are privileged and fortunate to live in this particular era when our technological capabilities finally allow direct observation and detailed study of visitors from other stellar systems. When we can actually examine in laboratories here on Earth materials that formed around alien stars in conditions completely different from our solar system's formation environment. 3i/Atlas, regardless of what it ultimately proves to be, regardless of whether December observations confirm it as an unusual but natural comet or reveal something more exotic and paradigm-shifting, represents an invaluable gift from the galaxy to our species. It's a test case that challenges our theories and understanding. It's a puzzle that forces us to refine our observational techniques and analytical methods. It's a prompt demanding that we think carefully about what we would need to see to distinguish between natural phenomena and potential technosignatures if they exist. It's asking whether we're intellectually ready to properly interpret the data the universe offers us, whether we can maintain appropriate skepticism while remaining genuinely open to revolutionary discoveries. December is approaching steadily and inexorably. The countdown continues with each passing day. The veil will lift when geometry finally allows Earth-based and Earth-orbital telescopes to observe the comet again. And we will finally witness what emerges from behind the sun, carrying answers that will either confirm our current understanding of interstellar objects and comet physics or transform that understanding in ways we cannot yet fully anticipate. Either outcome represents a triumph for the scientific method, for humanity's persistent drive to understand our place in the universe, and for everyone who refuses to accept "we don't know" as a final answer rather than as an invitation to investigate further and dig deeper. Thank you for journeying with me through this cosmic mystery. Thank you for your curiosity, your engagement, your critical thinking, and your willingness to consider possibilities beyond the conventional without abandoning rational skepticism. The universe is stranger and more wonderful than we typically imagine, and sometimes, just sometimes, it offers us glimpses that hint at just how strange and wonderful it truly is at its most mysterious. The story continues. The observations are coming soon, and we'll be here together to make sense of them when they finally arrive.